to 1, y1, y2 equals to 0, x1 equals to y minus 1, x2 equals to 0, 2 dx dy. Okay, where you can solve this easily to get the answer as a 1. Okay, easy, right? Okay, this is actually quite easy, but the solution is up to you, but you must understand the process actually. See, the skill is lot. I worried this on this kind of things, very small matter here. Okay, since if you start choosing this, for example, 1 0 1 0, finish, your effort gone. Okay, your effort gone. It's wrong, totally wrong. The solution you will get is wrong, right? Therefore, the range is very important. The knowledge must be very important here. Okay, now I'm going to teach you one more example. Okay, one more example, which is this example is also quite complex. Okay, but I make it a simple one, simple example I choose because it can be a very advanced, but I see now I have given 3 different examples. One, cylindrical, polygon which is made of tetra. Another one we're going to see spherical base. Okay, let us see how to handle the spherical. Okay, the spherical one is yi to j k. This is a ghost. Okay, exists over a surface as defined by x2 y2 z2 9 bounded by x greater than 0 y greater than 0 z greater than 0 in the first octant evaluate S F N ds. Did the question mention anything about you just find partially or something? No, that means you are required to find out the whole. Okay, depend on the question again. I repeat, I don't have much time to teach you everything, but I'm trying to teach the whole question. Okay, how to handle this? First of all, you need to sketch. Okay, you need to sketch. This is a spherical, right? Spherical, very clear. This is ghost. Don't touch ghost first. Okay, this is a ghost. Okay, this is a surface that you need to sketch. Okay, in order to sketch on this surface here, okay, this is the challenge begin. Okay, later I'll discuss about that. Okay, I call it as a B C O. Okay, now you need to find out the hold, okay, which is F surface of that 2, or maybe it could be 2 and BS. Okay, here if this is the case, ABC, OAB, OAC, OBC. Can or not? You need to find out all the surfaces here. Okay, all the surfaces. Then you get the hold. It's a very important. Okay, now the next stage, we go one by one. Okay, we go one by one and solve accordingly. Okay, first of all, I choose OAB. Okay, and this surface here. Okay, therefore I call it surface 1, maybe surface 1 O A B. OAB. Okay, in the OAB, the surface, when you go for the OAB, the surface is downwards, right? Can you see this? Okay. Outside. This is a external. Sorry. External. Okay, external. Okay. External pointer. Okay, it's an external pointer. Actually, we are looking at the external pointer here. Therefore, when you see this is the external pointer here, okay, it's externally, it's pointing to the world, external world. The most important is refer to the external world. Okay, this one, okay, is I didn't put this as a Z, X, Y. Okay, so far okay, can follow. Okay, in this case, if this is a scenario, what is the n? Definitely n is a negative k. Z is 0. But are we dealing with a straight line or x-like kind of things? No, it's a polar. Can you see that? Polar. Therefore, our D. Okay, sorry. First, let me finish this. Fn. What I'll get? Fn combine yi plus zk. It's actually 2k or 2. Sorry, this is not a 2. 2. Not a 2. It's not a z. 2 jk. Sometimes, I worried about this. If you don't see that and is negative k, therefore you will get a negative 1. Okay, and you get a negative 1 here. What is your ds? Your ds scale is very important. It's a r. R is what? Here. Can you see this? R is a square 2. That means x2, y2, z2 equals to 3 power 2. This is R. Okay, don't make the mistakes. I used to see many students, they just go and use 9 straight away. It's a 3. Therefore, R d theta dr. We need to use dr. This is 3, Remember, this is 3. This is 3. No doubt about that. Okay, but our skill is r d theta dr. Can you understand why? R d theta. This is a theta. Imagine this is a theta. R d theta. Okay, we are moving inside dr. Okay. Now, shall we calculate? Can we calculate or not? Yes, we can go and calculate this. Okay, in order to calculate this, I try to use this model here just because side by side. Because let me show you this part first. Okay, this part first. In this case, OAB, right? Okay. Okay. In this combine negative 1, okay, r d theta dr. Answer? Okay, what is this first? Okay, theta, of course we know, pi over 2, 0. 1 is a 3 to the 0. This is r. Okay, shall we? Can we find out this? Can. Okay, that means r theta is not there. Negative r theta pi per 2 to the 0. Okay, which is 3, 0, dr. Okay, therefore you will get a pi over 2 negative r. Okay, and 3 over 0 dr. Okay, can I go further? Can. This is a r squared. R squared over 2. Okay, now you get a negative pi over 2. Okay, in this case it's a 3 over 0. Then you just substitute inside, which you get a 3 over 2 here, which you get a negative pi over 2. Okay. You imagine that this is how you find out the formula for the whole spherical also. Okay, I don't have time to teach all these things, but it's this is how we can find out the whole, but let concentrate on this first. Okay, now I hope that you can follow. Now how to find out the OBC. Okay, OBC. Can we find out the OBC? Can. Okay, the OBC we need to find based on the F and TS again. Okay, what is N here? What is N? OBC? OBC here. Cannot see, right? OBC. This refer. Y, Z. Here, refer to the surface is going outside. Refer to X. Refer to X is a negative I. Now, opposite to that. X at this particular point is a 0. And F dot with the dot product with the end, we get a negative y, where the negative y is actually in a polar coordinate. You get a negative r sine theta. What about ds? Still same, r d theta dr. Okay, can follow or not? Equals to, I just bring it up here, say 3 0 pi over 2 0 negative r sine theta r d theta dr. Okay, can equate with this? Can you solve that? Can or not? I hope that you can solve. After this, I know that you can solve this very well. Okay, sine, concentrate only on the sine part. It's a negative cos theta. Here pi over 2 0, and that's a negative r square dr. Okay, rest I hope that you can solve. I think I didn't solve this completely yet. Okay, completely yet, but I hope that you can solve this is a solvable. Okay, it's not that difficult one. The next you will get here 0, here you will get a negative 1, therefore you get a negative r. The next one you will be r3 over 3, if I'm not wrong. You get a 3 over 0, or you get a something like r is a 3, right? 3 over 3 over 3. Okay, you can solve like this. Okay, so far okay? Can or not? Can, okay, what else to solve? The challenge is not here yet. Okay, the challenge is not here yet. The problem that I wanted to highlight to you, the most complex, and this thing is this one. Okay, So far I managed to solve this, I managed to solve this. Can I solve this one as well? Can you give a try? But I would like to solve for you A, B, C, which is most complex one. Okay, most complex part. Okay, at the moment, okay, do we have one more little bit to solve? Then after that I will take a simple break first, then after that we continue with the another one. Okay, the next one is we're going to solve OAC. Okay, we're going to solve the OAC. This one, OAC. Do we solve already? OAC, no, not yet. OAC. What about N? Okay, N is negative J, and OAC, the Y equals to 0 at that particular point. Okay, then this one is simple in that sense. F dot to the end, which you get a negative J, right? Negative J, you get a negative 2 as your solution. Okay, negative 2 as your solution. Okay, can I proceed to calculate? ds is r d theta d r. Okay, that means this also same. Okay, I get a negative 2 r d theta d r. Okay, what is this? Again say pi over 2, 0, 3 over 0. Okay, I want you all to solve this problem by yourself. Can or not? Okay? Done? Okay, the last one. The last one is the most, it's one of the very difficult these things to solve. And I may say this is not easy to directly to solve. The solutions for this, I didn't solve this. I don't have the solution with me at this moment. I'm looking for something that I can do. Find out the solutions here. Okay. Now, for this particular case, the solution is we're going to work on the very extensive way of solving this part. Okay, it's not a straightforward to solve. Okay, but I'm going to show you one by one how to handle this portion. The gauss is the challenging one is the gauss. Okay, the gauss that we're going to solve. Okay, now for the spherical part of that, okay, the spherical part of that, when you go and solve this one, ACB, okay, this is I need to show you the solution anyway. That's very important because okay, this one is a very complex one. This is a very complex to solve. A, B, C, we need to be very careful. Okay, I need to explain this very detailed. The first thing that I want you all to understand is this. Okay, okay, what is this? Again, I'm dragging the things first. Wait, I'm not dragging here. Okay, look at this surface. Look at this surface. Okay, first of all. Okay, what is the one way that to handle this? This is not a smooth surface anyway. Rest of the surface all smooth except this one is not a smooth. Okay, this is not a smooth. Okay, now I will say, can I use shadow? That is the first question. Can I use a shadow to solve this problem? No. I will not recommend to use shadow because shadow cannot be used in this case. Why? Can anybody guess this? Why you cannot use shadow to solve this problem? Because you see at this particular point here, okay, the shadow will go up, no problem. What about this? The shadow will go down. It's already what? 90 degree. Cannot. Therefore, if there is a 90 degree, okay, of the gradient, we cannot use, take a point, we cannot use shadow to do that. I don't have the paper at this moment with me. If you can remember that I did mention to you, if 90 degree, the shadow becomes 0. Okay, when you start calculate, it's become 0. Okay, therefore, I want you all to focus few things first. Okay, is that here and cannot determine normally in normal state, because it is not smooth surface. That's a more important. It's not normal. It's not normal. Sorry, what am I writing? 2 times I made the same thing. Okay, it's normal. You cannot determine normal method. Using normal method, we cannot use it's because it's not a smooth. The first thing that you need to use in order to do that is f x2 to the y is a 9. Therefore, I need to find out and using gradient. Okay, that is very obvious. Okay, I need to use a gradient. Therefore, it's become 2xi 2yj 2zk. Use this 2x2 2y2 2z 2 okay, and this will give you 2xi 2yj 2zk. Okay, 2 sometimes students get confused how to handle this part. Again, x2 y2 z2 is a 9. Okay, therefore here you get this is a, when you solve, this one is equals to top one here. Therefore 2xi plus 2yj 2zk divide by 2 to 9. Now you should able to handle here xi yj zk3. What happened to the 2? Okay, I cut off already. Okay, can you? Therefore, so far, okay, can follow. Okay, what about f end? F dot to the end. F. Okay, combine these two. What is f? F is y I 2j k xi yj plus zk 3. Then I you get a xy, you get a 2y z divided by 3. Can you This is look very complex, right? Yes, it's actually very complex. Okay, don't worry. We will try to solve this. I just give you the idea and hint to proceed to solve this problem. Okay, so far good to solve this. Okay, now what about the ds? The question is how to handle the ds. For the time, just I need to finish that. For the spherical method, x2 y2 z2 equals to r ds. Okay, I'll put this method cannot use shadow surface. Okay, I highlight this. Okay, because it actually it's a 90 degree. It may cause the you see when it's from the top here. See this, it's coming from the top here. It's already covered this. Okay, therefore when you take at this particular point and this particular point, it's already different these things. It may cover up to here. Okay, no, therefore you may have a problem at the end. Okay, therefore this two end will give you a 0. Therefore use actual surface to calculate. This is the challenge. Therefore, in order to use surface to calculate, okay, I don't have much this thing. I just very fast, I quickly again surface. Therefore we know this rho sine, I quickly phi. Okay, you pulled up. I repeated several times. I'm not going to repeat this time again. Okay, rho to d phi again here. Okay, please see the revision. Okay, this portion here is a rho sine phi. Okay, rho sine phi here. Okay, times with the d theta, right? Okay, I'm interested in this surface here. Therefore my ds is rho sine phi d theta whole thing here times with this rho d phi. Okay, quick revision only. Okay, the ds rho 2 sine phi d theta d phi. And what about x? X is rho sine theta sine phi cos with the theta. Y is equals to rho sine phi sine theta. Sorry, this is theta. Very sorry. This is theta. This is a phi. This is a theta. Sorry, and z is a rho sine phi. Okay, can follow or not? This is theta. Sorry again, sine theta. It's not a phi. Okay, now you just substitute this inside. Okay, this is the very long one. The people don't like this to see. I just put it here. F and ds. We're going to combine this. Okay, in actual sense, you're going to combine this. See, xy plus 2y plus z. Very huge one. Okay. ds here. ds is root 2 sine. Says here. Oh, cannot see, sine d theta d phi. Okay. Okay. Question. First we settle with this. Later we substitute everything inside. This become very long one. Very long question. But 1/3. Then I just choose here. What is this? What is this here? What is the choices here? Because d phi d theta. What is d phi d theta here? Okay, d phi d theta here. Can you? D theta is very simple, 90 degree, right? Okay, 90. Pi over 2, 0. No problem. What about d phi? Also 90. Also 90. It's go up only 90.